One more thing we need to learn with regards to volumes is something called Cavalieri's principle. Cavalieri came up with the idea that if two solids have the same height and the same cross-sectional area at every level, then they have the same volume. So basically, that the volume of an object that stands straight up is the exact same as an object that is leaning. So I attempted to draw two cubes, one standing straight and one leaning. That was horrible. So I went with cylinders instead. So if we have this cylinder that's straight up and down, think of like a can of green beans or something like that, right? And then we have the same shape but just pushed over at the top. So that's this shape right here. So we have, both of them have a radius of 7 meters and both of them have a height of 10. Now we measure height of this leaning tower from the base, from the top of the table if you will, straight up to where it's leaning. So if they both have a radius of 7 and a height of 10, then they're going to have the exact same volume. So you're going to plug in, your base area is going to be pi r squared for both of them. So pi times 7 squared, or 49 pi. And the heights both is 10, so you're going to plug in 10 into the same spot in both of them. So your volume is just pi r squared times 10 in both instances. So it's 490 pi cubic meters. So examples of how you might be asked about this principle, given a figure that has a volume of 108 cubic millimeters, what's the volume of figure B? And it tells you that their heights are congruent, although you don't know what it is. It tells you the radius here is 8, and if you can't see really closely, I don't know how well I can zoom in on this. Let's see. Oh, sorry for the blurriness. Okay, so that says 8. Alright, so this is the volume for both of them is 108 millimeters squared. So because they have the same because they have the same radius, because they have the same height, the volume of figure B is going to be the same as the volume in figure A. So if this is 108, this one's going to be 108 square millimeter or cubic millimeters as well. All right. Again, obviously, I'm better at drawing the cylinders and cones than the pyramids and prisms. But given the two figures have the same volume, what's the radius and height of figure B? So it tells you that these two have the exact same volume, and it gives you the radius and height of this figure. So figure A, and it's asking you to find the radius and height of figure B. Well, if you know the volume's the same, then the height's going to be the same, and the radius is going to be the same. So this is just going to be 11, and your radius, which would go right here, oh, excuse me, this is going to be 23. And your radius would be 11.